Hello, in this lecture we will find the area of triangle ABC in two different ways. In the drawing we have triangle ABC. We know that side AB of triangle ABC equals to 8 units. Side AC of triangle ABC equals to 14 units. And we also know that angle ACB, this angle, is angle X, or X degrees in size, and angle ABC equals to 2x degrees in size. Okay, and we want to find out the area of this triangle, triangle ABC. So first of all, we will draw line segment AD in such a way that so actually this point is point D. So we drew line segment AD in such a way that angle ADB also equals to 2x. Okay, angle ADB equals to 2x, and actually angle ABD equals to angle ADB. So actually in triangle ABD, this triangle, we have two angles that are equal to each other. And we have a rule number 1, that states if two angles in a triangle are equal to each other, if two angles inside a triangle are equal to each other, then the sides that are in front of those angles, the sides that are in front of those angles are also equal to each other. So I will read rule number 1 again. Rule number 1 states that if two angles inside a triangle are equal to each other, then the sides that are in front of those angles are also equal to each other. So for example, if we have triangle ABC. And in triangle ABC, we have two angles that are equal to each other. This is triangle ABC. And those two angles are equal to alpha. So angle ABC equals to angle ACB. Both angles are equal to alpha. So actually, we know that angle ABC equals to angle ACB, and those two angles equal to alpha. Then according to rule number 1, the sides that in front of those angles are also equal to each other. The side that in front of this angle alpha is AB, so AB will be equal to the side that in front of this angle alpha, that is to say AC. So actually AB equals to AC. So if we know that angle ABC equals to angle ACB, then automatically we can deduce that AB also equals to AC. Okay? Again, if we have in triangle ABC two angles that are equal to each other, those two angles are equal to each other. Therefore, according to rule number 1, the sides that are in front of those two angles are also equal to each other. That is to say, AB equals to AC. Okay? So, we can implement rule number 1 in our triangle ABC, because actually we have in triangle ABD we have two angles that are equal to each other. In triangle ABD we have two angles that are equal to each other. They are equal to they are equal to 2x. Therefore, according to rule number 1, AB, the side in front of angle 2x, that is AB, will be equal to the side that is in front of this angle 2x, that is to say AD, or AB equals to AD. Okay, so according to rule number 1, because in triangle ABD we have two angles that are equal to each other. Angle ADB equals to angle ABD, and both those two angles equals to 2x. Therefore, according to rule number 1, AB equals to AD. AB equals to AD. Okay, AB equals to AD. But we know that AB equals to 8 units. It is given us in the question that AB equals to 8 units. Okay? We know that AB equals to 8 units, so from this equality we can deduce that AD also equals to 8 units. Okay, AD, we can deduce from this equality that AD also equals to 8 units. Okay, so AD equals to 8 units. Okay, according to rule number 1. Okay, we have also rule number 2. Rule number 2 states that the exterior angle of a triangle equals to the sum of the opposite interior angles. So I will read rule number 2 again. According to rule number 2, the exterior angle of a triangle equals to the sum of the opposite interior angles. So actually, I will explain first of all what is exterior angle and what is interior angle. If we have triangle ABC, and this angle is angle alpha, this angle is angle beta, then those two angles are interior angles, okay? Those two angles are defined as interior angles. And in relation to this angle, and in relation to angle ABC, those two angles are considered as opposite interior angles, okay? In relation to angle ABC, those two angles are considered as opposite interior angles, okay? And what is exterior angle? If we extend line segment BC, if we extend side BC in such a way so if we extend line segment BC and we will call to this point L, then angle ABL this angle is defined as exterior angle. Angle ABL is exterior angle, and according to rule number 2, the exterior angle of a triangle equals to the sum of the opposite interior angles. So this exterior angle equals to the sum of the opposite angles. That is to say, angle ABL equals to alpha plus beta. Okay, so the exterior angle ABL equals to the sum of the angles of the opposite interior angles. So actually angle ABL equals to alpha plus beta, because alpha plus beta are considered to opposite interior angles. First of all, they are interior angles because they are inside triangle ABC, and they are opposite to this angle to angle ABC. Therefore, they are defined as opposite interior angles. So the sum of those two opposite interior angles equals to the exterior angle ABL, or ABL equals to alpha plus beta according to rule number 2. Okay, again, according to rule number 2, the sum of the two opposite interior angles, that is to say alpha plus beta, equals to the exterior angle ABL. So angle ABL equals to alpha plus beta. Okay, so actually we can implement rule number 2 in our triangle, because we have here, if we relate to triangle ADC, if we focus on triangle ADC, then this angle, those two angles, this angle DAC, and angle ACD that equals to X, are two interior angles, while angle ADB is the exterior angle, because we relate to triangle ADC, and in relation to triangle ADC, angle ADB that equals to 2x is exterior angle. So according to rule number 2, the sum of the two interior angles, that is to say angle ADC, this angle ADC plus angle ACD equals to the exterior angle, that is actually angle ADB, that equals to 2x. Okay? According to rule number 2, I write here, rule number 2, according to rule number 2, angle ADC plus angle DAC, that are two interior angles, equals to the exterior angle, that is actually 2x. Again, the sum of those two angles, if we relate to triangle ADC, in triangle ADC, those two angles are interior angles, and the sum of those two angles equals to the exterior angle, that is 2x. Okay? Again, the sum of those two angles, that is actually angle ADC plus angle ACD equals to the exterior angle, that is 2x, equals to 2x. But what is the value of angle actually this angle is angle DAC. Again, it is angle DAC. Angle DAC, this angle plus angle ACD equals to 2x. Again, the sum of those two angles that are interior angles, angle DAC plus angle ACD equals to the exterior angle 2x. Okay, but what is the value of angle ACD? Angle ACD equals to x. Okay, angle ACD equals to x. So here we have angle DAC. So we have the following equality that states that angle DAC plus x equals to 2x. So this is correct according to rule number 2. Angle DAC plus angle x equals to 2x. Angle DAC plus angle x equals to 2x. So here we can subtract x from this equality, and we will get that angle DAC equals to 2x minus x is x. So angle DAC equals to x. Okay, angle DAC equals to x. So actually, triangle ADC has two angles that are equal to each other. So according to rule number 1, the sides that are in front of the equal angles are also will be equal to each other. So the side that is in front of angle X, this angle X is AD, must be equal to the side that is in front of this angle X, that is DC. So according to rule number 1, AD in triangle ADC, in triangle ADC, in triangle ADC we have two angles that are equal to each other. Triangle ADC, we have two angles that are equal to each other, they are equal to x. So according to rule number 1, AD that is in front of angle x will be equal to DC that is in front of angle x. So AD equals to DC. AD equals to DC according to rule number 1 that states that in front of equal angles you have equal sides. Okay, so those two angles in triangle ADC are equal to each other, therefore in front of them they have also equal sides. That is to say AD equals to DC. Okay, according to rule number 1, AD equals to DC. But we have already found out that AD equals to 8 units. We found out that AD equals to 8 units. So from this equality, we can deduce that DC also equals to 8 units. Okay? From this equality, we can deduce that DC equals to 8 units. To 8 units. Okay, so DC equals to 8 units. Okay, So in the next step we have a new rule number 3. According to rule number 3, if you draw a perpendicular to the base of an isosceles triangle, isosceles triangle, then that perpendicular divides the base to two equal parts. So I will read rule number 3 again. According to rule number 3, if you draw a perpendicular to the base of an isosceles triangle, then that perpendicular divides the base then that perpendicular divides the base to two equal parts. So actually, if we have an isosceles triangle, we know the triangle ABC is an isosceles triangle. So ABC, triangle ABC is an isosceles triangle. That is to say, AB equals to AC. We know that AB equals to AC, and the base is BC. The base is side BC. So if we draw from point A a perpendicular to BC, that is to say, this is a right angle and this is a right angle, and we'll define the touching point between the perpendicular to side BC as point D. Then, according to rule number 3, the perpendicular to the base BC divides BC to two equal parts. That is to say, BD equals to DC. Okay, so if you have triangle ABC that is an isosceles triangle, and from point A you draw a perpendicular to BC, to the base BC, then that perpendicular divides the base BC to two equal parts, that is to say BD equals to DC. That is according to rule number 3. Okay, again you have triangle ABC that is an isosceles triangle, and you draw a perpendicular to the base from point A, then that base BC will be divided to two equal parts by the perpendicular AD. That is to say BD will be equal to DC. Okay, so actually we can implement rule number 3 in our triangle we relate to triangle ABD, that is, we know that AB equals to AD, so triangle ABD is an isosceles triangle because it has two sides that are equal to each other. Okay, so if we relate to triangle ABD, triangle ABD is an isosceles triangle. Again, this triangle ABD, is an isosceles triangle because of the fact that AB equals to AD. We know that AB equals to AD, therefore triangle ABD is an isosceles triangle because it has two sides that are equal to each other. AB equals to AD, so triangle ABD is an isosceles triangle. Then we will draw perpendicular to the base BD. We will draw perpendicular from point A to the base BD of the isosceles triangle ABD. And we will define the touching point between the perpendicular to side BC of the triangle as point E. Again, AE is perpendicular to BC, that is to say this angle is a right angle and this angle is also a right angle. It equals to 90 degrees. So according to rule number 3, the perpendicular AE divides the base to two equal parts, that is to say BE equals to ED. Okay, according to rule number 3, BE equals to ED. BE equals to ED because of the fact that the perpendicular AE divides the base BD to two equal parts, that is to say BE equals to ED. Okay, and if we define BE as A, we know that BE equals to ED, so ED also will be equal to A. Okay, so BE equals to ED equals to A. So we deduce this equality that B equals to ED according to rule number 3. So we know that BE equals to ED equals to A. ED, BE. So I write here BE equals to A according to our definition, and ED also will be equal to A because BE equals to ED. So we have here BE that equals to ED that equals to A. Okay, so we know that angle AEB is a right angle. This is a right angle. Angle AEB is a right angle. It equals to 90 degrees. Okay, so therefore triangle AEB is a right triangle. Triangle AEB, this triangle is a right triangle. Again, this is a right angle, angle AEB is a right angle, it equals to 90 degrees, therefore triangle AEB is a right triangle. Okay, again, angle AEB is a right angle, it equals to 90 degrees, therefore triangle AEB is a right triangle. That is to say, we can implement the Pythagoras theorem in the right triangle AEB. The Pythagoras theorem states that the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, AB square equals to BE square plus AE square. We will define AE as H. Okay? AE equals to H according to our definition because of the fact that actually AE is the perpendicular to side BD that is also perpendicular to side BC of the triangle. Therefore, if you have perpendicular to the base, that perpendicular will also defined as the height, that is the H. H is the abbreviation for height. So AE is defined as H, that is the abbreviation for height. So actually, according to the Pythagoras theorem, AB square equals to EB square plus AE square. But we know that AB equals to 8 units. Therefore, AB square is 8 square and 8 square is 64. 8 square is 64 equals to BE. BE equals to A according to our definition. So BE square is A square plus AE square. AE is defined as H according to our definition, so it is H square. So in total, we got question number 1 that states 64 equals to A square plus H square. Here we will subtract A square from equation number 1 and we will get that H square equals to 64 minus A square. So we found out that H square equals to 64 minus A square. Okay. So in the next step we will relate to triangle AEC, this triangle. Okay, actually we know that angle AEC is a right angle. We draw a perpendicular, so this is a right angle. So angle AEC is a right angle, it equals to 90 degrees. Angle AEC equals to 90 degrees. Again, angle AEC equals to 90 degrees. Actually, AE is the perpendicular to BD and to BC, so this is a right angle. Therefore, triangle AEC is a right triangle because it has an angle that equals to 90 degrees. Okay, so therefore, we can deduce from it the triangle AEC is a right triangle. Triangle AEC is a right triangle because it has angle that equals to 90 degrees. Angle AEC is a right angle. Actually, because of the fact that triangle AEC is a right triangle, we can implement the Pythagoras theorem on the right triangle AEC. According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So this will be equation number 2. The square of the hypotenuse AC square equals to the sum of the squares of the perpendiculars. The sum of the squares of the perpendiculars is EC square plus AE square plus EC square. Again, in the right triangle AEC, we implemented the Pythagoras theorem that states that the square of the hypotenuse equals to the sum of the squares of the perpendiculars, that is to say AC square equals to AE square plus EC square. But what is the value of AC? AC equals to 14 units. So AC square is 14 square. Square that is 196 equals to AE. What is the value of AE? AE equals to H. So AE square is H square plus EC square. What is the value of EC? EC equals to A plus 8. Again, EC equals to A plus 8. So EC square is A plus 8 square. Okay, so in total we got, in equation number 2, that 14 square equals to 8 square plus A plus 8 square. But we have already found out from equation number 1, we know that 8 square equals to 64 minus 8 square. So we can substitute 8 square in equation number 2 by 64 minus a squared, because h squared equals to 64 minus a squared. Okay, so we'll do it now. One 14 square is 196 equals to h squared. We'll substitute h squared by 64 minus a squared. Plus h squared is a squared plus 64 plus 16a. Okay, so in total we got this equality. Actually, here we have minus a squared plus a squared is 0, so a squared is cancelled. And 64 plus 64 is 128. Okay, so we'll get that 196 equals to 128 plus 16a. Okay, we got that 196 equals to 128 plus 16a. So here we will subtract 128 from this, from equation number 2, and we will get that 196 minus 128 is 68 equals to 16a. Okay, we got that 68 equals to 16a. Here we divide equation number 2 by 16 in order to get the value of a. Okay, and we will get that a equals to 17 68 over 16 is 17 over 4. Again, 68 over 16 is 17 over 4. Okay, I made the shortcut. So a equals to 17 over 4 units. That is a, BE equals to ED equals to a. So a equals to 17 over 4 units. After we found out the value of a, we have equation number 1 that states that h squared equals to 64 minus a squared. This is true from equation number 1. So we can substitute a squared by 17 over 4 squared. And we will get the value of h, that is the height of triangle ABC when the base is BC. Okay, so h squared equals to 64 minus a squared. 17 squared equals to 289 and 4 square is 16. Okay, here we will multiply 64 by 16 and then we will divide it by 16. Actually, we will take 16 as a common factor of this expression by dividing minus 64 by 16 and then multiply 64 by 16. Okay, we will get that h squared equals to 64 times 16 is 1024 minus 289 over 16, and 1024 minus 289 equals h squared equals to 735 over 16 . Okay, so I found out that h squared equals to 735 over 16. Here we will take a root out of this equality in order to get the value of h. Okay, we will get that h equals to the root of 735 over 16. But what is 735? It is actually equals to 5 times, it equals to 5 times 3 times 7 times 7, 16 equals to 4 times 4. Okay, so actually we got, so instead of 7,035, I wrote 5 times 3 times 7 times 7, that is equal to 7,035. If you don't believe me, you can check that this expression equals to 735 and 16 equals to 4 times 4. So the root of 7 times 7 is 7, and the root of 4 times 4 is 4. So we can take out 7 over 4 out of the root, and we will actually get that h equals to, here we took the root of 7 times 7 is 7, the root of 4 times 4 is 4. What is left inside the root is 5 times 3 is root 15. So in total we got that the height of triangle ABC equals to 7 over 4 times root 15, and we have already found out that A equals to 17 over 4 units. Okay, the height is also 7 over 4 times root 15 units. Okay, so actually we know what is the height of triangle ABC. We know the value of A. So actually, what is the area of any triangle? The area of any triangle equals to the base of the triangle times the height to the base. The height must create 90 degrees with the base, and indeed edge AE creates 90 degrees with the base BC. Therefore, AE, that is edge, it is indeed the height of triangle ABC. The base times the height to the base over 2 is the area of any triangle. Again, the area of any triangle equals to the base of the triangle times the height to the base over 2. So what is the area of triangle ABC? The area of triangle ABC, that is what we are looking for, equals to the base of the triangle, that is BC, times the height to the base. As you can see, AE, that is edge, indeed creates 90 degrees with the base BC. Therefore, AE is the height of triangle ABC because it creates 90 degrees with the base BC. So it is BC times h, the height is h, over 2. Okay, so the area of triangle ABC equals to the base of the triangle, that is BC, times the height to the base, that is h. The height creates 90 degrees with the base. So it is BC times h over 2. What is BC? BC equals to A plus 8. So the area of triangle ABC equals to BC, that is 2A plus 8, times h. We have already found out the value of h. H equals to 7 over 4 times root 15, all divided by 2. So the area of triangle ABC equals to 2 times A plus 8 times 7 over 4 times root 15 over 2. We have already found out that A equals to 17 over 4 units. So we can substitute A by 17 over 4 units. Okay, and we will get that the area of triangle ABC equals to 2 times A is 17 over 4, 2 times 17 over 4 is actually 17 over 2, plus 8 times 7 over 4 times root 15 over 2. So in total we got that the area of triangle ABC equals to 17 over 2 plus 8 times 7 over 4 times root 15 over 2. Here we will add 8 equals to 16 over 2. So we write it down. So the area of triangle ABC will be equal to 17 plus 16 over 2 times 7 times root 15 over 2. Okay, so the area of triangle ABC will be equal to 17 plus 16 is 33 times 7 times root 15 Here we have 4, of course. I forgot to write 4 here. We have 7 over 4 here, so here is also 7 over 4. So 2 times 4 is 8, and 8 times 2 is 16. So the area of triangle ABC equals to 33 times 7 is 231 times root 15 over 16 square units. So we found out that the area of triangle ABC equals to 231 times root 15 over 16 square units. Okay? Again, the area of triangle ABC equals to 231 times root 15 over 16 square units. Okay? So in the next step, I will present to you a second method to find out the area of this triangle, triangle ABC. We know that the sum of the angles in any triangle equals to 180 degrees. So actually, angle A plus angle B plus angle C will be equal to 180 degrees. Okay? The sum of the areas, the sum of the angles of any triangle equals to 180 degrees. So angle A plus angle B, that is 2x, plus angle C, that is x, must be equal to 180 degrees. Again, the sum of the areas in any triangle equals to 180 degrees. That is to say, A plus 2x plus x equals to 180 degrees. 2x plus x is 3x. So I write it down. So angle A plus 3x equals to 180 degrees. Here we will subtract 3x from this equality in order to get the value of angle A. So angle A equals to 180 degrees minus 3x in its size. The size of angle A is 180 degrees minus 3x. Okay, so the size of angle A equals to 180 degrees minus 3x. Actually, we have a new rule. Rule number 4. rule number 4 states that the area of any triangle, if we have triangle ABC and we know that the size of side AB is A units, and we also know that the size of side AC is B units, and we know that the angle between side AB and side AC is theta. Then, according to rule number 4, the area of triangle ABC, A is abbreviation for area, so A of triangle ABC, the area of triangle ABC will be equal to A times B times sinus theta over 2. Again, it is true in any triangle. In any triangle, the area of the triangle equals to the multiplication of side of AB by AC, or A times B times sinus theta over 2. Again, this formula is true for any triangle. Okay, we can define the area of any triangle by the it equals to the multiplication of the sizes of two sides, and then we will multiply it by the angle between those two sides. We will multiply it by sinus of the angle of those two sides, and then we will divide it by 2. So that is the area of this triangle, triangle ABC, or any other triangle. So we can implement rule number 4 in our triangle ABC. According to this formula, the area of triangle ABC will be equal to AB times AC times sinus 180 degrees minus 3x over 2. Okay, so the area of triangle ABC according to rule number 4 equals to AB times AC times sinus 180 degrees minus 3x over 2. But what is the value of AB? AB equals to 8 units. What is the value of AC? AC equals to 14 units. Sinus of 180 degrees minus 3x over 2. So in total we got that the area of triangle ABC equals to equals to 8 times 14 times sinus 180 degrees minus 3x over 2. And 14 over 2 is 7. 14 over 2 is 7, and 7 times 8 is 56. So I write it down. The area of triangle ABC will be equal to 56 times sinus sine 180 degrees minus 3x. Okay, that is the area of triangle ABC, 56 times sinus of 180 degrees minus 3x. Here we have trigonometric identity that states that sine of 180 degrees minus alpha equals to sinus sine alpha. Okay, we have this trigonometric identity that states that sinus of 180 degrees minus alpha equals to sinus alpha. So we can implement this rule in our triangle, and we will get that the area of triangle ABC equals to 56 sine of 180 degrees minus 3x equals to sine 3x, according to this trigonometric identity. Okay, so the area of triangle ABC equals to 56 times sine of 3x. Now we have a rule number 5. According to rule, actually it is not rule number 5, but it is the law of sines. The law of sines. According to the law of sines, in any triangle, we can implement the law of sines in any triangle. So if we have triangle ABC that can be any other triangle, not necessarily our triangle ABC, but any other triangle, so this is triangle ABC. The size of PC of triangle ABC is A. The size of AC of triangle ABC is B. And the size of AB of triangle ABC is C. Then, according to the law of sines, A over sinus A over sinus A equals to B over sinus B. Capital B is the size of angle of this angle. Equals to C over sinus C. Okay, So we can implement the law of sines in any triangle. Again, according to the law of sines, A over sinus A is the size of this angle, equals to B over sinus B equals to C over sinus C. And again, we can implement the law of sines in our triangle ABC. According to the law of sines, in our triangle ABC, we can implement the law of sines, and 14 over sinus 2x will be equal to 8 over sinus x. Okay, so actually this equality is the implementation of the law of sines in our triangle ABC. 14 over sinus 2x equals to 8 over sinus x. We have trigonometric identity that states that the value of sinus 2x equals to 2 sinus x times cosinus x. So actually this is the second trigonometric identity that states that the value of sinus x equals to 2 sinus x times cosinus x. Okay, that is the value of sinus 2x in this equality. So we'll write it down. 14 over sinus 2x is actually 14 over 2 sinus x cosinus x equals to 8 over sinus x. So in this equality we have sinus x in the denominator of this and on this side, and we have sinus x in the denominator of the other side of the equation. So we can cancel sinus x. We will cancel sinus x, and what is left after we cancel sinus x? First of all, 14 over 2 is 7. Here we will get it 7 over cosinus x equals to 8. Okay, we got that 7 over cosinus x equals to 8. So here we can multiply this equality by cosinus x and divide by 8. We will get that cosinus x equals to 7 over 8. Okay, from this equality we got the following equality, that cosinus x equals to 7 over 8. Now I will present to you a third trigonometric identity. The third trigonometric identity states that sinus square x plus cosine square x equals to 1. We will use the third trigonometric identity in order to find out the value of sinus x. Okay, from this trigonometric identity, we will subtract cosinus square x, cosine sinus x, sinus square x equals to 1 minus cosine square x. Here we will take a root out of this equality, and we will get that the value of sinus x equals to the root of 1 minus cosine square x. Okay, we know that cosinus x equals to 7 over 8, so cosinus, we can square this equality in order to get the value of cosine square x. Cosine square x will be equal to 49 over 64. So we can substitute cosinus square x by 49 over 64. We will get that sine x equals to the root of 1, and instead of cosine square x, we'll substitute it by 49 over 64, because it is equals to 49 over 64, and we got that sinus x equals to the root of 1 minus 49 over 64. Here, instead of 1, we will write 64 over 64. So we will get that sine x equals to the root of 64 minus 49 over 64. 64 minus 49 is 15. So sine x equals to 15 over 64. So sine x equals to root 15 over 64. The root of 64 is 8. So I write it down. We will get that sinus x equals to root 14 over 8. Okay, sinus x equals to root 15 over 8. But we have already found out that the area of triangle ABC equals to 56 times sinus 3x, and we know that sinus x equals to root 15 over 8. Again, we have already found out that the area of triangle ABC equals to 56 times sinus 3x. And we also found out that sinus x equals to root 15 over 8. What is the value of sinus x? Actually, it is the fourth trigonometric identity that states that the value of sinus x, sinus 3x, equals to 3 sinus x, 3 sine x, minus 4 sine cube x. Okay? According to this trigonometric identity, sine 3x equals to 3 sine x minus 4 sine cube x. Okay? So we can substitute sinus 3x in this equality by 3 sine x minus 4 sine cube x, and we will get that the area of triangle ABC will be equal to 56 times sine x. We have already found out that sine x, sine 3x actually, sine 3x equals to 3 sine x minus 4 sine cube x. Okay, so the area of triangle ABC equals to 56 times 3 sine x minus 4 sine cube x. Here we can take sine x as a common factor. We will take out sine x as a common factor of this expression, and we will get that the area of triangle ABC equals to 56, and we take sine x as a common factor, and in the brackets what is left is here 3, and here we took sine x as a common factor, so it is what is left in the brackets is minus 4 sine square x. Okay, in total we got that the area of triangle ABC equals to 56 times sine x. In the brackets we have 3 minus 4 sine 4 sine square x. Okay, so if sine x equals to root 15 over 8, we can square this equality in order to get the value of sine square x. So the value of sine square x, if we square this equality, the value of sine square x will be equal, root 15 square is 15, over 8 square is 64. Okay, so we found out that sinus square x equals to 15 over 64, and sinus x equals to root 15 over 8. So the only thing that is left here is to substitute sine x by its value, that is actually root 15 over 8, and to substitute sine square x by its value, that is 15 over 64. Okay, so we will do it now. We will get that the area of triangle ABC equals to 56 times sine x. Sine x is root 15 over 8. In the brackets we have 3 minus 3 square minus 4 times sine square x. Sine square x equals to 15 over 64. So in total we got that the area of triangle ABC equals to 56 times root 15 over 8. In the brackets we have here 3 minus 4 times 15 over 64. So here we can 64 over 4 is 16, so we can cancel 4 and 64. So the area of triangle ABC will be equal to 56 times root 15 over 8, 3 minus 15 over 16. Here, instead of 3, we can write 46 over 16, 48 over 16. 48 over 16 equals to 3. So we will get that the area of triangle ABC equals to 56 over 8 is 7, so it is actually root 15 times 7, 48 minus 15 over 16. So in total we got that the area of triangle ABC equals to root 15 times 7, 48 minus 15 over 16. 48 minus 15 is 33. So the area of triangle ABC equals to root 15 times 7. 48 minus 15 is 33 over 16. So the area of triangle ABC equals to 33 times 7 is 231. So we found out that the area of triangle ABC equals to 231 times root 15 over 16 square units. Again, the area of this triangle ABC equals to 231 times root 15 over 16 square units. Okay, so, and it is actually the same result that we found in the first method. So that is the implication that we did the second method correctly. Okay, so now I will summarize the lecture. Actually, we wanted to find out the area of triangle ABC, and we actually found the area of this triangle ABC in two different ways. We know that actually AB equals to 8 units, AC equals to 14 units, angle ACB is x, and angle ABC is 2x, and we want to find out the area of this triangle ABC. Okay, so actually we did a couple of constructions here, and okay, here first of all we draw line segment AD in such a way that this angle equals to 2x. So in this way we created an isosceles triangle, or triangle ABD. In triangle ABD we have two angles that are equal to each other, and according to rule number one, if two angles inside a triangle are equal to each other, then the sides that are in front of those angles are also equal to each other. So actually here we have triangle ABC. Two angles of triangle ABC are equal to each other. They both are equal to angle alpha. So according to rule number one, the sides that are in front of the equal angles are also equal to each other. In front of this angle alpha we have AB, and in front of this angle alpha we have AC. So according to rule number one, AB must be equal to AC. Okay, again, in front of this angle alpha we have side AB, and in front of this angle alpha we have side AC. So according to rule number one, side AB must be equal to side AC. Okay, and we actually can implement rule number one in our triangle. In triangle ABD we have two angles that are equal to each other. They both equal to 2x. Therefore, the sides that are in front of the equal angles also will be equal to each other. That is to say, the side that is in front of angle 2x is AB, and the side that in front of this angle 2x is the AD. So according to rule number 1, AB equals to AD. Okay? According to rule number 1, AB equals to AD, that because they are the sides that are in front of the equal angles. Therefore, they are equal to each other. So AB equals to AD. But we know that AB equals to 8 units. It is given us in the question. AB equals to 8 units. So from this equality, we can deduce that AD also equals to 8 units. Okay, AD also equals to 8 units. So AD equals to 8 units. And actually, triangle ABD is an isosceles triangle because it has two sides that are equal to each other. AB equals to AD equals to 8 units. Okay, and then used rule number 2. Rule number 2 states that the exterior angle of a triangle equals to the sum of the opposite interior angles. So rule number 2 states that this angle, that is exterior angle of triangle ABC, equals to the sum of the interior angles that are alpha plus beta. So the sum of those two interior angles alpha plus beta equals to the exterior angle that is ABL. So ABL, angle ABL equals to alpha plus beta. Again, the exterior angle ABL equals to the sum of the two opposite interior angles, or angle ABL equals to alpha plus beta. Okay, so we can actually implement rule number 2 in our triangle. We have, if we relate to triangle ADC, if we relate to this triangle ADC has this angle that is 2x, that is exterior angle to this triangle. So this exterior angle that is 2x must be equal to this angle plus this angle. So according to rule number 2, angle DAC, this angle plus angle ADC, angle ACD, angle ACD plus angle DAC must be equal to 2x. And again, angle DAC plus angle ACD must be equal to the exterior angle 2x. But what is the value of the angle DCA? The value of angle DCA equals to x. It is given us in the question. Okay, so angle DCA equals to x. So angle DAC plus x equals to 2x. We can substitute x from this equality, and we will get that angle DAC equals to x. So we found out that this angle also equals to angle x. So in triangle ADC we have two equal angles, and according to rule number 1, in front of equal angles we have equal sides. So according to rule number 1, in front of angle x we have AD, so it will be equal to the side that is in front of this angle, that is DC. So AD will be equal to DC according to rule number 1. Again, in front of equal angles we have equal sides. So according to rule number 1, AD equals to DC. But we know that we have already found out that AD equals to 8 units. Okay, we found out that AD equals to 8 units, so from this equality we can deduce that DC also equals to 8 units. So DC equals to 8 units. Okay, then we implemented rule number 3 in our triangle. Rule number 3 states that if you draw a perpendicular to the base of an isosceles triangle, then that perpendicular divides the base to 2 equal parts. So if this triangle ABC, is an isosceles triangle, that is to say AB equals to AC, then if we draw perpendicular to the base BC, then this perpendicular will divide side BC to 2 equal parts, that is to say BD equals to DC. Again, we have triangle ABC that is isosceles triangle, that is to say AB equals to AC. If we draw a perpendicular to the base BC from point A, then that perpendicular will divide the base BC to 2 equal parts, that is to say BD equals to DC. Okay, so we can implement rule number 3 in our triangle. Actually, we have triangle ABD. That is, triangle ABD is isosceles triangle because AB equals to DC. In triangle ABD, we have 2 equal sides. That is, for that reason, triangle ABD is an isosceles triangle. Therefore, if we draw perpendicular AE to the base BD, that is to say this angle is 90 degrees and this angle 90 degrees, then it will divide the base BD to 2 equal parts, that is to say BE equals to ED. Okay, we have isosceles triangle ABD, because AB equals to AD, therefore triangle ABD is an isosceles triangle. And if we draw a perpendicular to the base in the isosceles triangle ABD, then this perpendicular will divide the base BD to 2 equal parts, that is to say BE equals to ED. Okay, the perpendicular that we draw in the isosceles triangle will divide the base BD to 2 equal parts, that is to say BE equals to ED, according to rule number 3. And we defined ED as A, so ED equals to A, so therefore BE also equals to A. So we actually know that BE equals to A, ED equals to A, DC equals to 8 units, AC equals to 14 units, and AB equals to 8 units. Okay, then we draw perpendicular AE, therefore this angle is a right angle, therefore this triangle AB is a right triangle because it has one angle that is 90 degrees, therefore triangle AB is a right triangle. So in the right triangle AEB, we can implement the Pythagoras theorem that states that the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, AB square equals to BE square plus AE square. Again, in triangle AEB, the right triangle AEB, the square of the hypotenuse, that is AB square, will be equal to AE square plus BE square. AB square equals to BE square plus AE square, but we know that AB equals to 8, so AB square is 64, BE equals to A, so BE square is A square, AE equals to H according to our definition, so AE square equals to H square, from this equality, we got that h squared equals to 64 minus a squared. Okay, this is equation number 1. From equation number 1, we know that h squared equals to 64 minus a squared. But when we draw perpendicular from point A to BD, that perpendicular, it means that this angle is a right angle and this angle is a right angle. Because of the fact that this angle is a right angle, so triangle AEC has one right angle, therefore triangle AEC is a right triangle. So because of the fact that triangle AEC is a right triangle, we can implement the Pythagoras theorem in the right triangle AEC. According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. And so in the right triangle AEC, the square of the hypotenuse is AC squared equals to AE squared plus EC squared. So in the right triangle AEC, the implementation of the law, the Pythagoras theorem states that AC squared equals to AE squared plus EC squared. But we know that AC equals to 14 units, so AC squared is 14 squared. AE equals to 8, so AE squared is 8 squared. And EC equals to A plus 8. So EC squared is A plus 8 squared. And we have already found out that H squared equals to 64 minus A squared. So we can substitute H squared from equation number 2 by 64 minus A squared, because A squared equals to 64 minus A squared. So we substitute H squared by 64 minus A squared in equation number 2, and we have only one variable that is missing, that is A. So by solving equation number 2, we found out the value of A. We found out that the value of A is actually equals to 17 over 4 units. And we have equation number 1 that states that H squared equals to 64 minus A squared. Okay, and we have already found out that A equals to 17 over 3, so we can substitute A squared by 17 over 3 squared. Okay, we substituted A squared in equation number 1 by 17 over 4 squared, and we got the value of H. We have only one variable, that is H, and we found out that the value of H is actually equals to 7 over 4 times root 15 units, and we have already found out that A equals to 17 over 4 units. Okay, actually we know that we already found out the value of H. H equals to 7 over 4 times root 15 units, and we know the value of A. A equals to 17 over 4 units. So we know the value of BC because we know the value of A, that is 17 over 4. So the area of any triangle equals to the base of the triangle times the height to the base over 2. So the base of triangle ABC is BC, and the height is AE, that is H. So the base is BC, the height is H over 2. What is the value of base BC? BC equals to A plus 8. So BC equals to 2A plus 8. BC equals to 2A plus 8. And we know that H equals to 7 over 4 times root 15. Okay? And we have already found out that A equals to 17 over 4 units. So we have all the values in order to find out the value of triangle the area of triangle ABC, because we know that A equals to 17 over 4 units. So we have all the variables inside this equality. So we put the data inside this equality, and we found out that the area of triangle ABC equals to 231 times root 15 over 16 square units. Okay, so we found out the area of triangle ABC according to the first way, according to method number 1. Then we found out the area of triangle ABC according to the second method. So we know that according to the second method, we found out the area of triangle ABC. We know that the sum of the angles in any triangle equals to 180 degrees. So angle A plus angle B plus angle C will be equal to 180 degrees. So angle A plus angle B, that is 2x, plus angle C, that is x, will be equal to 180 degrees. So 2x plus x is 3x. So we found out that the value of angle A is actually 180 degrees minus 3x. A equals to 180 degrees minus 3x. And we found the area of this triangle ABC according to a new formula. We have rule number 4 that states that the area of any triangle equals to A times B times sinus theta over 2. The area of any triangle equals to A times B times sinus theta over 2. Okay? That is the area of any triangle, because triangle ABC can be any triangle. So we can implement rule number 1 in our triangle. So the area of this triangle according to rule number 4 will be equal to AB times AC times sinus 180 degrees minus 3x over 2. Okay, according to rule number 4, the area of triangle ABC will be equal to AB times AC times sinus 180 degrees minus 3x over 2. We know that AB equals to 8 units, AB equals to 8 units, AC equals to 14 units, AB equals to 8 units, AC equals to 14 units, and this angle equals to 180 degrees minus 3x. So it is sinus 180 degrees minus 3x over 2. And so we found out that the area of triangle ABC equals to 56 times sinus 180 degrees minus 3x. And we have the first trigonometric identity that states that sinus of 180 degrees minus alpha equals to sinus alpha. So according to this identity, the sinus of 180 degrees minus 3x equals to sinus 3x. So in total we got that the area of triangle ABC equals to 56 times sinus 3x. Okay? And then, so this is the first equation. The first equation states that the area of triangle ABC equals to 56 times sinus of 3x. Then we implemented the law of sines in our triangle ABC. According to the law of sines, in any triangle, A over sinus A equals to B over sinus B equals to C over sinus C. Okay, in any triangle, this identity is true, that A in the red color over sinus A equals to B over sinus B, the size of this angle, equals to C over sinus C, that is the size of angle of this angle. Okay, so we implemented the law of sines in our triangle ABC, according to the law of sines, 14 over sinus 2x will be equal to 8 over sinus x. Okay, according to the law of sines, 14 over sinus 2x equals to 8 over sinus x. Okay, so we have here sinus 2x, and the value of sinus 2x is 2 sinus x cosinus x. Again, the value of sinus 2x, according to this trigonometric identity, equals to 2 sinus x cosinus x. So instead of sinus x, we can write 2 sinus x cosinus x. So we have sinus x in the denominator of this side of the equation. We have sinus x in the denominator on the other side of the equation. So we can cancel sinus x. And after we canceled sinus x, we found out that cosinus x equals to 7 over 8. Then we used third trigonometric identity in order to find out the value of sinus x, because we have this equality that states that the area of triangle ABC equals to 56 times sinus 3x. So we have to find out the value of sinus x in order to find out the area of triangle ABC. So according to this trigonometric identity, sinus square x plus cosinus square x equals to, or sine square x plus cosine square x equals to 1. Here we subtracted cosine square x from this equality, and then we take a root out of this equality, and we got that sinus x equals to the root of 1 minus cosine square x. We know that cosine x equals to 7 over 8, so if we square this equality, we will get the value of cosine square x. And we got that the value of cosine square x equals to 49 over 64. So we can substitute cosine square x by 49 over 64, because it is equal to 49 over 64. Okay, so we substituted cosine sinus x by 49 over 64, and we found out that sinus x equals to root 15 over 64, or sinus x equals to root 15 over 8. Okay, sinus x equals to root 15 over 8. And we have the previous equation that states that the area of triangle ABC equals to 56 times sine of 3x. And we already found out that sine x equals to root 15 over 8. So we have the third trigonometric identity. The value of sinus 3x equals to 3 sine x minus 4 sine cube x. So we can substitute sinus 3x by this, because they are equal to each other. We can substitute sinus 3x by 3 sinus x by minus 4 sine cube x. Okay, so here we substituted sinus 3x by this expression, and we got that the area of triangle ABC equals to 56 times 3 sine x minus 4 sine cube x. Then we took out sine x as a common factor of this expression, and inside the brackets what is left is 3 minus 4 sine cube x. Okay, and we have already found out that sine x equals to root 15 over 8. So we know that sine x equals to root 15 over 8. If we square this equality, we will get that sine square x equals to 15 over 64. So here we actually can substitute sinus x by root 15 over 8, and we can substitute sinus square x by 15 over 64. Okay, so we substituted sinus x by root 15 over 8, and we substituted sinus square x by 15 over 64, and we got that the area of triangle ABC equals to 231 times root 15 over 16 square units. Again, the area of this triangle ABC, equals to 231 times root 15 over 16 square units. And it is exactly the same result as we got in the first method. Exactly the same result, 231 times root 15 over 16 square units. Okay? Thank you very much.